Hello dear students, and welcome to Unit 4. In this unit, we are going to speak about Introduction to Heat Transfer. And we will explore the fascinating world of heat transfer. Heat transfer is a fundamental concept in physics and engineering. Heat transfer governs how energy moves between objects or systems, and understanding it's crucial for solving a wide range of real-world problems, from designing efficient cooling systems to understanding natural phenomena like weather patterns. So guys, we will start by discussing the three primary modes of heat transfer: conduction, convection, and radiation. So guys, let's get started. Okay, so we will focus on the fundamental mechanisms of heat transfer. These mechanisms, conduction, convection, and radiation, they explain how heat energy moves from one place to another. Each plays a unique role in both natural phenomena and the engineered systems. Conduction involves heat transfer through direct contact, such as the warmth you feel when touching a hot metal surface. As for convection, convection occurs when heat moves through a fluid, driven by differences in temperature and density, like the way warm air rises. What about radiation? Radiation is the heat transfer through electromagnetic waves, allowing energy to travel even through a vacuum like the sun's heat reaching Earth. Okay, and we will carefully examine each mechanism, highlighting their principles and the real-world applications. So let's start with conduction. The process of heat transfer through direct contact. This mechanism occurs when thermal energy moves between particles or molecules, typically in solids. Factors affecting conduction: thermal conductivity of material, temperature difference between objects, area of contact between objects, distance between the objects. Examples of conduction include, for example, a metal spoon in hot soup, touching a hot pan handle, and ironing clothes. For example, the heat from the iron is conducted to the fabric, removing wrinkles. Heat transfer through walls of the house in winter. The cold air outside causes heat to flow from the warmest interior through the walls. Let's move on to convection. Heat transfer through the movement of fluids such as air or water caused by temperature differences. As for types of convection, the first one is natural convection, driven by density differences like hot air rising. The second is forced convection, driven by external forces like a fan circulating air. Examples of convection include boiling water, hot air rising above a fire, a sea freeze or land freeze caused by pressure differences. Convection is critical in natural systems and engineering, influencing everything from weather systems to the design of efficient cooling systems and heat exchangers. Finally, let's discuss radiation, the transfer of heat through electromagnetic waves. Unlike conduction and convection, radiation doesn't require a medium to transfer energy. It can occur even in a vacuum. All objects emit thermal radiation based on their temperature, and the higher the temperature, the more energy they radiate. Factors affecting radiation: temperature of emitting surface, emissivity of the surface, area of emitting surface. Examples of radiation include sunlight warming the earth, a microwave oven reheating food, a fireplace radiating heat. Radiation plays a key role in many applications, from designing thermal insulation to understanding climate systems and creating efficient energy technologies, like solar panels. Okay, so heat transfer is not just a theoretical concept. It has practical applications in almost every aspect of our lives and industries. Understanding heat transfer mechanisms enables us to design and optimize processes, devices, and systems that rely on efficient energy exchange. And here you see some applications of heat transfer. They include power generation, internal combustion engines, refrigeration and air conditioning, electronics, cooling. Heat transfer analysis. Step 1, define the problem and identify the mechanisms. In this step, you should carefully analyze the system and define the parameters that will guide your calculations. Step 2, apply conservation's law. Step 3, solve the governing equations. And step 4, interpret the results. So you should analyze the results and understand the heat transfer behavior and its applications. Heat transfer plays an important role in many aspects of everyday life, influencing the way we interact with the environment, use energy, and maintain comfort. And it's important and spans across different fields such as cooking, home heating, and cooling, and also transportation and electronics. And here you can see how heat transfer is fundamental in various aspects of daily living. Heating and cooling, cooking, clothing insulation, and solar energy. So dear students, that is the end of our video session for today, and next time we are going to speak about mass transfer. Be sure to join us for the next video session. Thank you for your attention. Goodbye.